Hi, class. So, welcome to our unit on electricity. And I think you know this already if I ask about that branch of science that deals with electricity. Can you still remember it? It is what? It is physics, right? So, physics is that branch of science that deals with electricity. So, it should be an enlightening unit. Now, at this point, I want you to get a loose leaf out and write your name, homeroom, and the date today, and fill in the blanks here. Essential questions 1, 2, 3, 4. GRS strategy 1, 2, 3. Okay. Now, with electricity, something to think about. So, these are now our four essential questions here. One, what is electricity? Where does it come from? What do we use it for? And how would your life be different without it? So give it a thought. Now, with electricity, everything in the world is made up of atoms, right? And each atom is made up of smaller parts. And one of those parts is called an electron. So the idea of electron is that it is a flow of electrons. So think about our solar system, the sun being in the middle or the nucleus, and the planets. You can think of the planets are the electrons now. Now, electrons are negatively charged and they can quickly move from one atom to another. Now, in this unit, we will mention two types of electricity: current and static electricity. Static electricity. Now, this is the charge that stays on an object. These charges are usually created through friction. Charges can then jump from one object to another. And examples of static electricity include static shocks and lightning. Current electricity is the one that you're most familiar with. This is the type of electricity used in our homes. Therefore, the steady flow of electricity can be called an electric current. A current will move along a wire or a path called a circuit. Circuit means to go around. Now, we might have a simple activity on drawing circuit diagrams. And sometimes we call this the schematic circuit diagrams, represented by lines, by circles, and as much as possible, we use rulers here, and we can clearly see the right angled here. And what's the degree here? 90 degrees, right? Now, circuit components are symbols which are simple and they usually look similar to what is happening. For example, copper wire. So we simply represented it as a straight line like this, a connecting wire like this. A light switch can be represented like this, like there's a break in here. So that you can turn it on and off. Toaster can be represented as a resistor or a load. And your AA batteries, we usually represent it as vertical lines like this. Other examples include two or more batteries, right? A light bulb, commonly we have it as a circle with an X. Voltmeter, a good essential question to ask also would be, what is a voltmeter or what is an ammeter? But in a circuit diagram, we usually have the letter V there to represent voltmeter and A for ammeter. Now, the cell, you're mostly familiar with the word batteries, right? So that cell stores chemical energy and transfers it to electrical energy when a circuit is connected. Now, when two or more cells are connected together, we call this a battery. The chemical energy inside a cell is carried by electrons from the negative terminal to the positive terminal and is used up as it pushes current around the circuit. And usually in a battery, you can clearly see the positive side or the negative side there. Now, this more on the cell. There are many different types of batteries depending on application. There are rechargeable batteries which can be used over and over again, and one use or the disposable batteries. Now, the chemistry inside the battery determines how many times it can be used and how long each charge will last. Now, let's have a little bit of an understanding of open versus closed circuits. If you just look at these two diagrams here, you can see closed as in closed, like really like this, right? Now, open, if there is a break in here, you can see this. Yes. So here, a circuit can be described as either open or closed. Closed circuit, the circuit is operating and the current is flowing. That is, the light switch is on and so are the lights. Open circuit, the circuit is not operating, okay? The light switch is off and so are the lights. Now, what is an electric current? Now, an electric current is a flow of microscopic particles called electrons flowing through wires and components. Very important. I'll go slow on this. Electrons flow from the negative terminal to the positive terminal of a cell, but current runs from positive to negative. Types of circuits. When you did the poster, you might have encountered this word series circuits and parallel circuits. And notice how the attack on this unit is now being explored. We'll let the students build on their prior knowledge first about a certain unit. Remember, there was less of direct instruction coming from me as a teacher. So it's only now that I'm trying to just kind of clear up some misconceptions if there are misconceptions during your research or readings, as the case may be. So, series circuits and parallel circuits. Now, series circuits, the components are connected end to end, one after the other, just like this. They make a simple loop for the current to flow around. But then if one bulb blows, it breaks the whole circuit and all the bulbs go out. Parallel circuits are represented this way. The components are connected side by side. The current has a choice of routes. So if one bulb blows, there is still a complete circuit, so the other bulb will stay lit. So if I have here a certain component, um, the bulb is off or it blows up, then you cannot use this gadget or component. But there are other lines that may be open so long as it's connected with a specific object in the house. Now, let us mention again some of these terms that we will be using the word current. So, the flow of electricity around the circuit is called current and runs from positive to negative. Current, we will have some problem solving later on. Yay. We represent it as a letter I. It's measured in amps or letter A here and is the amount of electrons passing a given point in 1 second. Remember, electricity is the flow of electrons. Therefore, if we um, try and remember the idea of current, it's the amount of electrons there. So columns, or let us see here, is a different unit. So 1 amp, it says here, is the amount of electrons passing a given point in 1 second. 1 amp is equal to 1 coulombs per second, or 6.25 times 10 to the power of 18 electrons per second. Just imagine so many electrons in a given second. Therefore, if the current flowing through a wire, toaster, or hair dryer is 1 amp, that means that 6.25 times 10 to the power of 18 electrons flowed past that point every second. Now, in science, it might be different with math. We have what we call as the GRS strategy of problem solving in science. So we write down what is given, what you can read from the problem. Required is what is being asked, and S stands for solution. And commonly we start with a formula, or if there is a conversion factor, we can just write it down. So it's not giving me the final answer right away. It's just like dealing really with the scientific process. We deal with steps. So let's say, checking your understanding now. How many electrons pass a point every second if the current is 2 amp? So how would you do that? So given, so here I can write down given is 2A, 2 amps. What are we asking for? Electrons, okay? Electrons. And solution, I might as well start with this conversion factor because this was mentioned, right? 1 amp is 6.25 times 10 to the power of 18 electrons per second. So how would you solve this problem? So you are asked how many if you have 2A here. So that means you simply what? Multiply. So we can just say electrons now equals to what? The same number, right? So let me just copy this down. And then multiply by 2. And usually we kind of avoid using the letter X to mean multiplication, right? Because it might be interpreted as another variable. So this number multiplied by 2, I would not use x2, but instead I will say times 2 this way. And of course, the difference now of science with math mostly would be we take care of our units, okay? So 6.25 times 10 to the power of 18 times 2. How would you solve this using your calculator? Now I have here somewhere, I think I have it here, an online calculator, right? So here, for instance, I would just have 6.25 times 10 to the power of 18. And then I'm just going to multiply this by 2, right? So let's see what comes up. So 1.25 times 10 to the power of 19. So if I go back here, the answer would be 1.25. And let me just copy this. Times 10 to the power of 19th. And of course, do not forget the unit. That would be the number of electrons per second. Okay, so this is how we solve now problems in science. You might say, oh, it looks complicated, Miss F. No, not really. You just put down GRS, given required solution. Just writing that, sometimes I give you 1 mark right away. You know what you're looking for, another 1 mark. Solution, you have a formula, 3 marks. And then you start plugging in the answers. You have a value here, and then that's 1 mark, and then a unit of measurement, another 1 mark, for a total of 5 marks per problem. Now, this hopefully this will click in a memory in your head when you dealt with density problem solving when you were in grade 8, right? So we kind of adopted the same strategy of problem solving in science, where we wrote down given required solution. So this is the first problem. Now, this is the second problem for you guys. How many electrons pass upon? Oh, I think we're done with this. Sorry about that. So I think this is something that you can consider. This can be the second problem. How many electrons pass a given point every second if the current is 12.6 A? So on your loose leaf, what is given here? 12.6. So if you have 12.6 amperes, amps, you're asked how many electrons would there be? Hmm, give it a thought. Let's see if I have more on this lined up. And this is the third problem. What is the current if 3.125 times 10 to the 18 electrons pass a point every second? So again, go by our first example, right? Give it a try, and I'll give you some time to just process through this short DI so that you can figure things out. But we'll come back to it together in class, okay? Because I know this is being lined up for you guys. So let's have a preview of this. So it would be drawing of simple circuit diagrams or schematic diagrams, okay? So I'll just end my short DI on this, people. Try the check your understanding uh, questions, right? Or go back to your loose leaf, because I think that's what I initially asked you to just take out, right? So that you can just concentrate on this, okay? So I'll end with this. You can now take a moment to go back to your loose leaf and just process the answers to the essential questions and the two problems involving the GRS. Okay, so that's it. Thank you. Thank you, class, for listening. Ciao for now.